everyone. Today we are going to go over the density problems, the density application problems. So recall density is mass divided by volume. So number one, a wooden cube has an edge length of 4 centimeters. And we know that that's a cube. So knowing that it's a cube means that it's a square on each side. And being that it's a cube, all dimensions are 4. And it has a mass of 43.264 grams. Determine the density of the cube. So to determine the density, the first thing we need to find is volume. So volume of a cube is area of the base times the height. So my base is a square. So that's 4 times 4 times the height, which is 4. So that's 64 centimeters cubed. Now to find our density, we do mass divided by volume. So our mass is 43.264 grams divided by our volume, which is 64 centimeters cubed. We do that division on our calculator. And we get that it's 0.676 grams per centimeter cubed. Then looking at our chart, that means that this cube is made of maple. Number 2. Trees that are cut down and stripped off of their branches for timber are approximately as cylindrical. A timber company specializes in a certain type of tree that has a typical diameter of 50 centimeters and a typical height of 10 meters. So we need to, first of all, think about that we need those to be the same units. So if we recall, there are 100 centimeters equals 1 meter. So what I'm going to do is I'm going to take my diameter and divide by 100 centimeters and get that it's 0.5 meters. The density of the wood is 380 kilograms per cubic meter, and the wood can be sold at a rate of $4.75 per kilogram. Determine and state the minimum number of whole trees that must be sold to make $50,000. All right, so first of all, first thing we need to do is we need to find our volume. So volume of a cylinder is pi r squared h. So we're going to do pi. Our diameter is 0.5. So our radius is 0.5 divided by 2, which is 0.25. So that's 0.25 squared times our height, which is 10. So we do that on our calculator, which gives us that is 1.963495408 cubic meters. Now our density is 380, and we need to figure out how many kilograms we have. So our density equals mass divided by volume. Our density is 380. Our mass is what we're looking for. And we have our volume, which is 1.963495408. So to solve that, what I do is I cross multiply because 380 is over 1. So I get mass equals 380 times that number there, which gives me a mass of 746.1282552 kilograms. Now that we know our mass, we know that I can sell it for $4.75 per kilogram. So I'm going to multiply that by 475. So one tree earns $3,544.11. Because when I do the mass of one tree by 475 per kilogram, I get that it's 35,444. So to find out how many trees get 50,000, I do 50,000 divided by 3544.11, and I get that I need to sell approximately 14 trees. A minimum number to make at least that much. So actually, since it's 14.10, I'm going to say that I need 15 trees. Because we're okay if we make more than 50,000, but we need to make at least 50,000. So I want you to pause, and I want you to try number 3 and come back and check. Okay, so first thing I'm going to do is I'm going to find my volume, which is area of the base times the height, or in the case of a rectangle, it's really just length times width times height. So it's 14 times 16 times 10. And that gives me a volume 2240 cubic inches. Since I know there's 2016 cubic inches, to find out the empty space, I do 2240 minus 2016, which gives me 224 cubic inches. And they want the percent. So I do 224 over the total, which is 2240. And that's 0.1, so 10%. So it's choice 1. Number 4. So again, I want you to pause and do 4 and 5, and then come back and check. So to help you out before you pause and do this, I'll tell you that the volume of a ball is 4/3 pi r cubed. So pause and try to do this. So number 4, I did the volume of the basketball is 448.9. The volume of the tennis ball is 8.18. And then I divided the basketball by the tennis ball, and I got that the answer is choice 3. So we're going to stop there for today. If you have any questions, please let me know in class, and we'll go over number 5 tomorrow.